Hello everyone, I am ATUL NEGI and I welcome you all to IMS Gate Academy YouTube platform. So we have started our Theory of Machine Foundation course and we are discussing gear train topic. Already we have discussed about the gear classification and we have discussed the introduction part of the gear train as well, where we have talked about the simple gear train and the compound gear train, right? And I hope everyone is enjoying this foundation course where we are focusing on the fundamental and the basic parts. Right? If you are enjoying this foundation course on theory of machine, do subscribe to IMS Gate Academy YouTube platform because you will be getting all those important informations and important lectures, important topics will be covered in this particular YouTube platform. Okay. A very good evening, Matan. Very good evening. Right. So today in this particular session, gate train part 2, we'll be discussing the riveted gate train and the epicyclic gate train. Right. Already two previous gate trains we have already discussed. Audio clear? Okay, thank you, Mathan. Now, riveted and the epicyclic we have to discuss. And if you look at the previous year problems from the gate train topic, mostly question came from the epicyclic one, right? So, just a small discussion we will have on the riveted and then we'll directly go to the epicyclic and we'll start solving previous year problems, right? So, let's get started, guys. Before starting the lecture, I will suggest you to join this Telegram group where you will be getting all the lecture PDFs, okay, whatever lectures we are conducting in this IMS Gate Academy YouTube platform, all the lecture PDFs you will be getting there. Apart from that, latest job notifications and daily quizzes are happening, which will help you in your exam preparation, right? Apart from that, we have started our live online program where you will be getting more than 800 hours of live sessions. And these live sessions are totally interactive. You can directly discuss your doubts in the class, in the live class itself, right? Apart from that, you will be getting GATE question bank booklet and theory book and the exercise book for every subject. In the exercise book, all the questions have been categorized in 3 levels, level 1, level 2 and level 3 based on the difficulties, easy, moderate or hard questions, right? You will be getting a live doubt solving portal where you can post your doubts. Just click a photo of the question and upload it. You will get the solution, right? Apart from that, we will have IMS Gate Academy online test series also, which starts from the chapter level, subject level, and then finally full length mock tests are there. So you will be getting all those important features which is required in your GATE preparation, and one more feature which is the main important feature of this IMS Gate Academy, which is the live mentorship sessions. Mentorship sessions means the one-to-one sessions. You and the faculty will be there and he will guide you. He will help you in making the strategy for this GATE 2025 examination. If you are facing any challenge in any of the topic of any of the subject, you can discuss that topic or your doubts also personally with the faculty with one-to-one sessions. So these sessions will help you to get the best result in the GATE examination. So if you are interested in this program, directly you can call on this number, okay? Directly you can call on this number and our counseling team will help you to enroll in IMS Gate Academy live online GATE program. So let's get started, guys, with the topic here, gate train, right? So if I talk about the classifications of gate train, if I talk about classification of gate train, it will start with simple gate train, compound gate train, riveted and epicyclic. Already we have discussed this first and second one in the last session, right? I hope you don't have any doubt regarding the first and second one. We have solved numerical also. We have discussed all basic important details of the gate trains, right? I hope it is clear to everyone, right? And till now, whatever the topics we have discussed, like flywheel, mechanism, velocity analysis, acceleration analysis, degree of freedom, single slider crank mechanism analysis, whatever the topics we have discussed from the basic fundamental point of view. See, in the preparation of any competitive examination, we need to focus on the basic fundamental because this is the foundation. If your foundation is strong enough, all the concepts, all the fundamentals are good enough, you have understood it, okay? If you have a good command over that, you can easily solve the difficult or the advanced topics also, okay? You will never face any difficulty in understanding the advanced topics. Majority of the students face difficulty in understanding advanced topic or the difficult topics because the foundation is not good enough. They have not understood the basic and the fundamental parts. That is the biggest problem that many students are facing, because they are not focusing on the fundamentals. That's why this foundation course we have curated for you, so that you will never face such problems in your preparation. Okay, so this is not for just GATE examination. If you sit for any other technical competitive examination where mechanical engineer is, questions will be from mechanical engineering, so you will be benefited from this particular foundation course. Various subject foundation course already we have discussed: strength of material, fluid mechanics, right? And this is the theory of machine. So if you are enjoying this session, do share the sessions with your friends as well, and do subscribe it, because you will get always the notification when we are going to conduct a live session, right? So it will help you out. Now, so we'll start with the reverted gate train, guys. Now, if you look at the important point in the reverted gate train is the axis of the first and the last gear will coincide. Axis of first and the last gear will coincide. Just try to visualize what kind of gate train it will be. What kind of gate train it will be when the first and the last gear axis is coinciding, right? Now, I will show you some images here of this reverted gate train. Now, consider this gate train. Gear first is in meshing with gear 2, gear 2 and gear 3 are on the same shaft, and then 3 meshing with the 4. Gear 1 and 4 don't have any direct connection. They don't have any direct connection, or we can say they are not in meshing also, and they are not on the same shaft also. So there is no direct connection between gear 1 and 4. But there is one thing which is common. The axis is what same. Axis is what same. So such type of gate trains are considered as reverted gate train, where the first gear and the last gear have the same axis, right? So you can consider this as the first gear here. Right, and you can consider this one as the last gear. Right, so this is a very important point. Now, if you say, sir, gear 2 and 3 are compound gears, yes, absolutely, because they are on the same shaft. Same speed of rotation will be there for gear 2 and 3. Same sense of rotation it will be there. So whenever a shaft contains more than one gear, we already discussed that it is called as compound gear. One shaft carries more than one gear, compound gear. If it carries only one gear, each shaft will have only one gear, then the gate train is known as simple gate train, right? Now, easily we can write down the velocity ratios here also. There is no issue, because 1 and 2 in meshing, the relation we can write directly is N1 by N2, T2 by T1. N1 by N2 equals to T2 by T1. Directly we can write this relation. Then 3 and 4 are in meshing. So this is relation number 1. N3 by N4. N3 by N4, right? So N3 by N4 will be T4 by T3. This is equation number 2. Now we can use these two relations to solve any of the unknown parameter that they will be asking in the question. Okay, so as I told you, the axis of the first gear and the second gear, first and the last gear is same. So what I can say, the distance, this center distance, okay, this distance, let's suppose CD, center distance I'm saying, it will be same, right? I can write the R1 plus R2 equals to R3 plus R4. Are you getting the point? From this particular arrangement, I can write R1 plus R2, okay? This is the radius of gear 1 and this is the radius of gear 2. R1 plus R2 equals to this R3 plus R4. Right? Now this relation is also important, because sometimes some of the data they will not give. But using this relation, we can directly find out those data which is not given in the question, right? So R1 plus R2. Now, how we can write R? Already I told you that module equals to dia by number of teeth. That dia can be written as twice of radius divided by number of teeth. So your radius actually equals to module multiplied by number of teeth divided by 2. Right? Now, gear 1 and 2 are in meshing, so definitely they will have a same module, because that is the condition. If two gears are in meshing, then they will definitely have same module, otherwise they cannot mesh. Similarly, gear 3 and 4 are in meshing, so they will have definitely same module. Okay, so we can write it here. So let's suppose module of gear 1 and 2 is M. So M T1 by 2, M T2 by 2. Here let's suppose the module of 3 and 4 is M dash, for example, M T3 by 2, M dash T4 by 2, like this. So this is another one relation we are having. So try to understand. These relations are very, very important. Using these three relations, we can solve any of the riveted gate train problem. Is this point clear? We can solve any riveted gate train problem, no matter how much it seems to be a difficult question. We can solve all of the problem of riveted gate train. There is no problem in that, if we know how to write these relations. Because whatever they are going to ask, all questions can be solved using these three relations. Using these relations, we can solve any of the unknown parameter, right? So direct velocity ratio between gear 1 and 2, another ratio between 3 and 4. And most important point here that you need to write, that speed of 2 and 3 is same. That is N2 value equals to N3. So this is also a very important relation, because they are the compound gears. Both gear 2 and 3 are on the same shaft. That is why. And then R1 plus R2, R3 plus R4. Why I have written M dash? It is not necessary that whatever the modules 1 and 2 is having, same module 3 and 4 will have. It is not necessary. That's why I have written M dash. Just to have a distinction between the module of these gears and modules of these gears. Just for a distinction. Maybe all the gears will have same module. That is also a possibility. But it is not necessary that always all gears will have same module. But module of 1 and 2 will be same. That's why M I have written. 3 and 4, M dash I have written. Is it clear? I hope. Right? So no matter what kind of question they have asked, you need to know how to write these relations. That's all. Only that much is required in the riveted gate train. Clear? So the point you need to remember here is the axis of the first and the last gear will coincide. Done? Now, see, this is another format of the gate, another format of the riveted gate train. So here this is the first gear. This is the first gear and this is the last gear. 1 and 2 meshing, 2 and 3 on the same shaft, 3 and 4 meshing. So 4 is the last gear. Okay, so you can easily identify. Okay, this is the first gear. This one meshing, and this one is meshing. And the axis is coinciding. Because axis is coinciding, that's why this distance will be what? Same. If I consider gear 1 and 2 or 3 and 4. That's why R1 plus R2 equals to R3 plus R4. Like that relation we can write. Okay. Until unless it is not mentioned that gear 1 axis and gear 4 axis are not coinciding, in that case I cannot write R1 plus R2 equals to R3 plus R4. In that case I cannot write. So what you need to remember, the axis of first and the last gear is same. That's why R1 plus R2 equals to R3 plus R4. Right? So same velocity ratios also you can write here. So again, gear 1 N1 by N2 T2 by T1. That is the first relation. N1 by N2 equals to T2 by T1, right? Then 3 and 4. N3 by N4 equals to T4 by T3. That is relation number 2. And as this axis is same, so we can write R1 plus R2, R3 plus R4. And directly I will tell you, remember this formula, mt by 2. If I have to write the radius, mt by 2 is the formula for writing the radius. Okay, R3, mt3 by 2, but I will keep m dash here so that we can consider the module of 3 and 4 is different. mt4 by 2. So this is the another relation. I hope it is clear. Now coming to the next gate train, epicyclic gate train. One of the most important topic of the gate train, right? Every year you will see one of the questions are coming from the epicyclic. Majority of the questions are from epicyclic gate train, and sometimes I've seen also students are having a fear about this epicyclic gate train, how to solve it, because there is a complete table we have to create. Okay, and sometimes if a big gate train comes, then entire table becomes also big and complex procedure will be there. Okay, totally complex procedure will be there, and then you will get confused in writing all those steps in the table, and you will get the wrong answers also. But we are not using that method. We are using the smartest approach of gate train analysis, that is the relative velocity method. That is relative velocity method. Okay. Now, what is epicyclic gate train? Very, very important point. Okay. See, in epicyclic gate train, what is going to happen? The axis of the gear wheel can rotate about the axis of other wheel in addition to revolution around their respective axis. See, if a gear is there, it will rotate about their own axis. That is okay, fine. But if that gear is rotating with respect to another gear axis also, so there will be two motions will be involved. Gear rotating about rotating about its own axis, that is one kind of rotation. Gear rotating about its own axis, that is one kind of motion. But if the same gear which is rotating about its own axis, that gear is rotating with respect to another gear axis also, that is the secondary motion. Is this point clear? So such cases of the gate train are known as epicyclic gate train. Right? Now see here. Let's suppose this is the one gear, first gear. This is the another gear. Now easily the meshing can happen between this blue gear and the green gear. Meshing will happen. So let's suppose if it rotates clockwise, it will rotate anti-clockwise. Simple. There is no problem. But let us assume if I connect both the gears with the arm here. If I connect both the gears with the arm like this, so then there is a possibility that this green gear which was this blue gear which is rotating about its own axis, now it can rotate with respect to the axis of the green gear as well. If the arm was not there, then it is rotating about its own axis. Rotating about its own axis. Now, with the help of this arm, it can rotate like this. It can rotate like this. So, there will be two motions involved. So, such type of gate trains are known as epicyclic gate trains. Okay. So, let us assume it is, let's suppose, fixed at this end. This arm is fixed at this end. So now we can consider that this blue gear can rotate about its own axis also, and as well as it will rotate like this. Like this. Like this, it will have a motion. Is that clear? So possibility is there. Right? The possibility is there. So that's why. Please understand this point. Axis of the gear will rotate. It can rotate basically about the axis of other wheel in addition to revolution around their own respective axis. That is the epicyclic gate train. Now, how to solve or how to analyze such type of gate trains, let us consider one example. Let us consider one example, right? Arm rotates at 100 RPM. Arm rotational speed they have given as 100 RPM. In clockwise direction also given. Find the speed of gear B when gear A is fixed. If TA value 24, TB value is 30. So let us write down the data here that they have provided. First of all, I will write down the data. Arm rotates, so speed of rotation of arm is 100 RPM. Okay. In clockwise direction. Fine. Speed of gear B when gear A is fixed. So when gear A is fixed, its speed of rotation will be 0. That is what a common sense here. Na? If it is fixed, so then how it will have a speed? So that's why it is 0. Number of teeth on gear A is 24 and number of teeth on gear B is 30. Right? Clear? So this is the gear A we are having and this is the gear B we are having. Right? And this is what we have as arm. This is what arm we are having. Okay. Now gear A is fixed, they have mentioned. Okay, gear A is fixed. Done. Is it clear till this point? Any confusion, any doubts, you should ask in the live chat box, right? Whatever the doubts you are having regarding this epicyclic gate train, you should ask. Right? I hope it is clear like how the two motions are there. One motion is about its, okay, one motion was about its own axis. Another motion is with respect to this. With respect to this, another center or axis of another wheel, another gear. So about this axis, this blue gear will be rotating like this. So that's why two motions are involved. Clear everyone? Done? Okay. Now, so as I told you, the first basic approach that we usually studied in our college also, okay, the conventional method of analyzing any gate train. So that method maybe you have studied in your college also, okay. So that method again I am going to discuss here just for the understanding point of view. And then next we will be using the relative velocity method, right. So just for understanding purpose we are discussing that method. In that method, what is the step number 1? So step number 1 is what? We will create a table like this. The first column will be of motion, then arm A and B. Total 3 elements are there. Please understand. How many elements in the gears in this particular gate train system? Gear A, gear B and the arm which is connecting gear A and B. Total 3 elements are there, right? So total 3 elements. Now considering the first part, motion. Now I will assume a motion here, please see. But I will assume arm is fixed. That is what I am assuming. Arm is fixed and gear A is having a plus X revolution. Gear A is having a plus X revolution. Now first of all, I will tell you this point also. Plus X means what? The sign convention, guys. This sign convention also you should keep in your mind, like whenever solving gate train problem. So ultimately sign convention is depending upon you, okay. So whatever the sign convention you will follow, accordingly you will get the answers. Let us assume for clockwise I am taking positive sign and for counterclockwise or anti-clockwise I will consider the negative sign. Vice versa also you can consider. Anti-clockwise, counterclockwise as positive and clockwise is negative. That basic point you should keep in your mind. So once you have fixed this sign convention, and then we will follow that one only. Okay, so you can follow the reverse also, it's your choice totally. But whenever you are solving a question, fix a sign convention, don't confuse yourself only. While solving a question, don't confuse yourself, okay. So that's why first fix the sign convention. Now, we have created this table. So first column, that is motion. But we are assuming arm is fixed. Arm is fixed and gear A is having a plus x revolution. So when arm is fixed, what will be the speed of rotation of arm? 0, right? For gear A, plus x we have assumed. Okay, fine, plus x. But what about for B? Now, please understand here, gear A and B are in meshing. So arm 0, A plus x. For B, I can write like this, NB by NA equals to TA by TB, right? But a negative sign will be coming. Now you will say, sir, why the negative sign? Negative sign comes because the A and B is having external meshing. And external meshing means what? The sense of rotation will be different. If A rotates clockwise, B rotates anti-clockwise. Clear? So using the velocity ratio relation, NB by NA equals to TA by TB. So your NB value from here will be equals to minus NA into TA by TB. So finally NA value is what? X. So minus X TA by TB. Yes or no? Is it clear? How I've solved for the speed of rotation of gear B? How I've solved for speed of rotation of gear B? Because A and B direct meshing, right? So I can write down this relation, velocity ratio relation. So this minus X TA by TB is the speed of rotation of gear B that we have figured out, right? So let me just erase this part. I hope now you have understood how we have solved minus X TA by TB. So let me erase this part here. Got it? So minus X TA by TB from the velocity ratio relation, we got the answer. Fine. So based on the first step in the table, the very first step that we are going to take here is the arm is fixed and the speed of rotation of gear is plus x. Right? That is the step number 1. Now second step, please see. Add minus x revolution to all elements. Add minus x revolution to all the elements. If I do so, what will happen? Arm minus x, right? A minus x I have given. Then B also minus x I have given. See, what is the second step? I have given minus x revolution to all the elements. It means the entire gate train we have provided this minus x revolution. Is this point clear? Now you will say, sir, why you are considering this step? What are the logics behind those steps? Please understand here. If I don't add minus x here, no, then ultimately what will happen? A will have some velocity, which is not possible as far as the given question is concerned. Because in the question, what they have mentioned about gear A, it is fixed. So what should be the resultant value of the gear A? It should be 0, right? That's why minus x I have given to all the elements of the gear train. If I do so, then what happens? Total. Now total additions I will do. I will add, because 2 motions I have considered. This is the step 1. This is the step 2. 2 motions I have considered. Now I will add the values here. So if you add the value, arm will have minus x, A will have 0, which is true as far as question is concerned, and gear B minus x TA by TB. Finally, we got the answers of arm speed of rotation of A, which is 0, and this is the speed of rotation of gear B. Now actually, after doing so, from this table we got these answers. Now what advantage we got here? What is the advantage? Advantage is here is, what is the advantage? Advantage is we have related all the elements rotation speed. Rotation speed of all the elements are now related. How it is related? See, arm is x, A 0, fine, and B value is in terms of x. So basically, we have established the relationship between different elements of a gate train. We have established a relationship between different elements of the gate train. That is what the outcome of this tabular analysis, tabular format analysis we have done. Na? So that table we have created here, because of that we got the relationship between different gears. So minus x is the speed of arm, 0 for A, and for B minus x TA by TB. Relationship we got for all the elements. Now all the elements speed we have, based on the value of x, I will tell the value of B also easily. No need to do any other calculation. No need to do any other calculation. With the help of minus x, I can tell the value of b also directly, because I've solved the value of rotation, the value of the speed of rotation of gear B in terms of speed of rotation of arm. That relation I've established here. Done? Now, coming back to the question again, guys, please see. Speed, number of T's of A and B are 24, 30. It is there. Arm 100 RPM clockwise they have mentioned. This data I will be using now. Okay, this data I am going to use. So, first step, speed of rotation of arm minus x from the analysis we have done. From the table we are getting what? Minus x. That minus x equals to what? 100 RPM. That minus x value will be equals to 100 RPM, because from the question it is given arm speed is 100 RPM. From the table analysis we got arm speed as minus x. So, minus x should be equals to 100. Clear? Minus x value should be equals to 100. So, minus x from where we got? From the tabular analysis that we have done. We have considered two steps. From that analysis we got speed of rotation of arm minus x. In the question it is given 100. So, minus x equals to 100. So, x value is what? Minus 100. X value will be what? Minus 100. Speed of rotation of gear A is 0. Now, NB directly we have a formula here, minus x TA by TB. Minus x value 100, 100, 100. TA 24, TB was 30, 180 RPM we got finally. 180 RPM is the answer of speed of rotation of gear B. I hope you have understood the steps that we need to take. Again, I will repeat here. Please understand. Step first and second, these are the common steps in all the gear train analysis of epicyclic gear train. The step first is consider arm to be fixed and A is having a plus x. So, in this case it is A. You can consider any other system, any other gears also. As far as this gear train is concerned, please see. As far as this gear train is concerned, how many elements was? 3. You can have a gear train in which 4 elements are there, 5 elements or 6 elements are also there. In that case, such type of analysis that we are doing here will become a totally lengthy process, and sometimes we will do some mistakes also. So, whole process become lengthy process, and where the chances of mistakes are very, very high. Chances of mistakes are very high. So, that's why I am telling here, in this case it is seems to be what? Very easy. As far as this gear train problem is there, in this case this conventional approach is what? Very easy, because hardly 3 elements are there, but as the elements, number of elements is going to increase, complexity of this conventional approach also increases, right? So, step 1, arm fixed, and any gear will have a plus x revolution, then give minus x revolution to all the elements. And why we are doing so? Because we want to, whatever the fixed gear is there, for that finally resulting answer should be what? 0. So, we got finally, the last step will tell the different relationship. From the last step we are getting the relationship between the different gears. In this case 2 gears are there, maybe more than 2 gears or more than 3, 4 gears are also possible. So, we can say we will get the relationship among the different gears. Among different gears we will get a relationship, and from that relationship we can find out the answer. Okay. So, 180 RPM is there. Finally, we got this answer. Okay, fine. Now, coming to the relative velocity method, which we will be using in the competitive examinations like GATE examination, BARC, BARC, ISRO, all AE and JE examinations. Will be using a smartest approach, that is the relative velocity approach. Clear? Okay. Now, please, each and every step you have to be what? Very careful. Okay. Now, see. So, considering this as a gear A, this is as gear B, and this is what we have as arm. Now, what I will write first of all, see, speed of rotation of gear A with respect to arm. Relative velocity of gear A with respect to arm. Right? How I am going to write this one? Speed of A minus speed of arm. That is the relation. Now consider gear B speed of rotation with respect to arm. That is NB value. NB value with respect to arm. So NB minus N arm. NB minus N arm. Right? Clear? These two relations, I hope it is clear to everyone. So I will write the speed of gears with respect to arm. So how I will be going to write? How I will write here? Speed of gear, then speed of arm. Take the difference because I am considering the speed of gear A with respect to arm. So speed of gear A minus speed of arm. That is what we are going to write here. Fine. Now one more thing. Gear A and B are in meshing. Gear A and B are in meshing. Right. So when these gears are in meshing, I can write the velocity ratio relation. I can write the velocity ratio relation. Speed of gear A with respect to arm. Considering arm as a reference point. Considering arm as a reference point, guys. So speed of A with respect to arm and B with respect to arm. As I know A and B are in meshing, I will write down the velocity ratio like this. TB by TA. Now again Y minus sign because of external meshing, sense of rotations will be opposite. Sense of rotation will be opposite. I hope it is clear everyone. Now if we have written this relation, now what I will do? I will again put the values of this one and this one in this equation. So A with respect to arm divided by B with respect to arm minus TB. Okay, arm we have considered as a reference point of view. Okay, so A with respect to arm will be written as NA minus N arm, NB minus N arm, TB by TA. Now as far as our question is concerned, the data that they have given, okay, let us see the data. Data was given as arm 100 RPM clockwise. Same sign convention I will follow. Arm speed of rotation 100. For A it is 0, B we have to find out. TB value 24 and 30, right? Now we will put the data here. A value 0, arm was given 100, divided by B we have to calculate minus 100 minus 30 by 24. Now from here you can calculate and tell me the value of speed of rotation of B. What is your answer here? Please quickly everyone calculate and tell me your answers. What will be your answer? A very simple calculation and it must be same. Okay, if any differences are there, so please let me know. (180 RPM), right? Correct. Now, answer you will be getting in positive. So when answer you are getting in positive, it automatically means clockwise, because clockwise we have assumed na initially positive. If it comes in negative, if the answer comes here in negative, we will say anti-clockwise sense of rotation. So now you can see how it is easy to use this relative velocity method to calculate the answers, whatever they've asked regarding the epicyclic heat train. So what I need to do in relative velocity method, I need to consider arm as a reference point, right? I will consider that. Now second thing, we will see which gears are in meshing. A and B are in meshing. So what I will directly write this relation. I will directly write this relation. Speed of A with respect to arm divided by speed of B with respect to arm. A and B are in meshing. It will be equals to minus TB by TA. And finally is all the values I am going to put here, I will get the answer. Within 1 minute you will be getting the answer from this. Within 1 minute. And I am telling you this thing. Okay, and I can guarantee you, you will say 1 or 2 minutes in the gate train problem if you use relative velocity method. If you use relative velocity method, you will be saving time. Okay, but if you use conventional approach, definitely it is going to take more time. And in the gate examination, it is all about the time management. No matter how much level of knowledge you are having, no matter how much confidence you are having, okay, but if you are not able to solve the questions within the given time, then ultimately you are not able to have a good score in the gate examination. In order to have a good score in the gate examination, you need to attempt maximum questions. I am not saying you attempt all 65 questions. At least you need to attempt more than 50 questions. And if you are investing more than 5 or 10 minutes in one question, then how it is possible for you to solve even 50 questions also? That's why in the starting, let's suppose you have entered in the examination hall and you are writing the gate examination, you need to attempt the first questions, only those questions you need to attempt first in which you are confident, where you are totally confident about the steps that you are going to take, and finally you will get the answer. So in your mind, it should strike you, yes, this question I should solve first. Okay, this question I should not solve first because I didn't get an idea. I didn't get an idea how to solve this question, what should be the process, okay, what should be the procedure here, what are the steps I need to take in order to get the answer. So if these points are not clear, better skip it. It is better to solve in the starting only those questions in which you are having confidence. You are clear about the process that you are going to use to solve the question. Right? So please, these all important things, these are all important things which is very necessary in the examination. Okay, at home you are practicing without any time frame, then you can take whatever time you want. But in the examination, there is a time clock is running. So we have to think about how we have to invest our time, right? And we should not waste more than 5 to 10 minutes in any one question. Sometimes we are in a flow ki, okay, I know this topic, I have practiced so many questions, but I will solve it, no matter if it takes 5 minutes or 10 minutes. Ultimately, you are affecting your paper only. So that's why this is very important. Time management in the gate examination is very, very important. Now, coming to next question, guys. This is the next problem from GATE 2016. Now, in this question, please read the question very carefully. In the gate train shown, gear 3 and gear 3 is carried on the arm 5. Gear, okay, carried on arm 5. Okay, arm they have mentioned with 5. Okay, gear 3 meshes with gear 2 and 3 in meshing, fine. Okay, and the number of gear number of teeth actually on the gear 2, 3, 4 are 60, 20 and 100 respectively. Gear 2 is fixed. Okay, gear 2 is fixed, they have told. Okay, fine, we will consider gear 2 as fixed. So let us mention these lines here so that we can easily understand that gear 2 is fixed. Gear 4 rotates with angular velocity of 100 rpm in counterclockwise. Okay, counterclockwise. Okay, accordingly you should mention the sign. Angular speed of arm they are asking. So see here how we will solve. So first of all, I can write 2 and 3 are in meshing and 3 and 4 in meshing. So first of all, 2 and 3 in meshing. Speed of rotation of 2 with respect to arm. Okay, instead of writing 5, I am just writing it as arm. Speed of rotation of 3 with respect to arm. It will be equals to minus T3 by T2. Relation number 1. Now, gear 3 and 4 are in meshing. Gear 3 and 4 are in meshing, right? 3 with respect to arm divided by 4 with respect to arm. Here it will be T4 by T3, but instead of negative, here positive sign will be coming. Reason, because 3 and 4 is having internal gear meshing. Sense of rotation will be same. That's why we have used the positive sign here. Fine. Now, you will think, sir, speed of arm they are asking, so how we can solve? 3 for gear 3, they have not mentioned anything. I have written these two relations just in order to see these two relations how I have written directly, because from the diagram it is clear 2 and 3 in meshing, 3 and 4 in meshing. Whichever gears are in meshing, I can write down the relative velocity ratio. Relative velocity ratio we can write, so I have written that one. Now, just focus on these two relations. If I multiply both these relations, what is going to happen? denominator of relation 1 and numerator of relation 1 or relation 2 basically are same, so it will get cancelled out. So finally 2 with respect to arm divided by 4 with respect to arm, and you will get minus T3 by T2 multiplied by T4 by T3. So we'll write down here N2 minus N arm, because 2 with respect to arm will be written like this and 4 with respect to arm. Right. So here, okay, T3 will get cancelled out, so minus T4 by T2. Now, based on the data given here, right, what is the data given? Gear 2 is fixed. So 0. Speed of arm we have to calculate. We will write it like this. Speed of 4. Okay, 4 rotates with an angular velocity of 100 rpm in counterclockwise. Counterclockwise I am assuming negative. So minus 100 rpm. Okay, minus T4. What is the T4 value they have given? 2, 3, 4. 4 is 100. And what about 2? It is 60. It is 100. And what about 2? Gear 2, 3, 4. 60 it is there. So from here, speed of rotation of arm you can calculate. Please mention your answer in the chat box, guys, everyone. So speed of rotation of arm you have to calculate here. Okay, do it fast. What will be your answer here? So that basic calculation we should do it. Okay. So if you solve here, answer will come out to be minus 62.5 rpm. Now if minus sign is coming, it is simply clear that from this minus sign it is counterclockwise. Counterclockwise. Clear? So if you see the option here, 62.5 counterclockwise, option C is the correct answer. Option C is the correct answer. Clear? Now next question, guys. Again 2001 question, all of the data they have given here, and what they are asking, for the number of teeth shown in figure in the gears, the arm rotates at, again arm value they are asking, speed of rotation of arm, right? So this is sun, this is arm, this is planet, and this is ring. So first of all, sun and basically this planet gear, sun and the planet gear are connected with the help of arm. So sun and planet are in meshing, and similarly planet and ring are in meshing. So we can easily write here the speed of rotation of sun with respect to arm divided by speed of rotation of planet with respect to arm minus Tp by Ts. Why minus sign? Because of external meshing between sun and planet gear, because of external meshing, right? Now planet and ring, they are having what? Internal meshing. So planet Np with respect to arm, speed of ring with respect to arm, plus Tr by Tp. Tr by Tp it is there. Fine. Now these are the two relations. Just multiply both these two relations from 1 and 2. We can write speed of sun with respect to arm, speed of rotation of ring with respect to arm equals to minus Tp by Ts multiplied by Tr by Tp. Tr by Tp, like this. Easily we'll get the answer of arm. Okay, we'll further expand this one. Speed of sun minus speed of arm divided by speed of a ring minus speed of arm. Right, minus Tp by Ts multiplied by Tr by Tp. Right, so Tp will get cancelled out. And what about the values here? All the values they have mentioned here itself. So you can easily get the answer. Sun, they have mentioned 100 RPM driven clockwise. Okay. Now one more important thing. Please carefully understand. These lines are representing what? That ring gear is fixed. Okay. And it is already mentioned in the question also. Ring gear is held stationary, which is fixed. So ring will have 0. Minus Tr by Ts. So from here, speed of rotation of arm you can easily calculate, because Tr value they have given us, okay, number of teeth on ring 80 and number of teeth on sun it is mentioned as 20. So you will get the answer very easily. Okay, so do it fast and tell me your answers here. Okay, what will be your answer here? Okay, in this case this minus and this minus will get cancelled out, and Tr they have mentioned as 80 and Ts they have mentioned as 20. So 80 divided by 20 it will be what? 4. Okay, so 4 times it will get cancelled out here from here. Then so 4 n into arm and then one more 5. So finally 20 RPM you are going to get the answer from here very easily. Okay, so see 100 minus n arm, this minus sign will get cancel out with this minus sign. Tr was 80 divided by 20 into n arm. Okay, because from n arm minus n arm will get multiplied here now. So 100 minus n arm, this is 4 n arm, minus if it goes there, so 5 into n arm equals to 100. So n arm equals to 20 RPM. That is what the answer we have solved finally. Done. So like this we can solve any of the epicyclic gate train. In the next session guys, we are going to solve much more problems from this epicyclic gate train only from the previous year gate examination. So gate previous year questions from the epicyclic gate train, okay, we will be solving in the next session. I hope you have understood the concept how to solve any epicyclic gate train problem with the relative velocity ratio method. We have discussed the conventional method also, but as I told you, if the gate system or the gate train becomes big, the whole process becomes complex, okay, and it is more time consuming also. That's why relative velocity method we are going to use here, and we have seen that if I use that method we will save time. So why not we have to use, okay, we should use this one. I hope everything is clear guys. So I will end the session today here itself. In the next session, that is on tomorrow, we are going to discuss all of the previous year gate questions from epicyclic gate train. Right? Thank you so much guys. We'll meet you tomorrow.